Alright, we are moving on to the Protist kingdom. And we call the Protist kingdom the junk drawer kingdom because a lot of the organisms are very, very different from each other. Very similar to a junk drawer. You see that none of this stuff really is similar to the other stuff in the drawer. It doesn't fit anywhere else in the house, so we just kind of shove it in here. And this is kind of just that catch-all, this place where we stick things that we don't know where they go. We call it the junk drawer. The organisms are very, very different from each other. They don't fit in the other kingdoms. So they have some similarities with the other kingdoms, but they don't quite fit. So we just kind of stick them in this category with all the other organisms that don't fit. Protists do have some things in common, though. They are all eukaryotes. They're going to have a nucleus. They all live in very moist and wet areas, and most of them are unicellular. The protists are going to have three different categories or subcategories. We call them animal-like protists, fungus-like protists, and plant-like protists. It is very important that you use the phrase animal-like or fungus-like or plant-like because we have to remember that these are not actual animals, fungus, or plants, but they're just similar to animals, fungus, and plants. So they have similarities to these categories, but they're not similar enough to be put in those kingdoms. So be sure to use the proper terminology and say animal-like protists instead of saying animal protists. The animal-like protists, the reason why we call them animal-like is because they're heterotrophs, just like animals are. They eat other organisms. They can't make their own food using the sun. However, they are not like animals because they're unicellular. In the animal kingdom, every single organism is multicellular. So to put a unicellular organism in the animal kingdom, it's just not going to work. They all have more complex systems, body systems, and so forth. And unicellular organisms are way more simple and should not be classified the same as those multicellular organisms in the animal kingdom. Also, they can move, just like most animals can move as well, and they are classified based on how they can move. So we put them into three different subcategories in the animal-like protist category. So some animal-like protists move with pseudopods. Let me get my pointer here. Give me a second. So you see the word pseudo. Pseudo means false, and pod means foot. And all of these little projections here are the pseudopods of this organism called an amoeba. And they're basically just a cell membrane right around the outside, and then this is just cytoplasm that just pushes outward and forms that pseudopod. Amoeba is the most common animal-like protist with pseudopods. You can see over here, these are also the pseudopods of this amoeba. Kind of see here's the cytoplasm oozing out, close, pushing on the cell membrane, creating a pseudopod. Here's some more pseudopods over here forming. Okay. And pseudopods can also help the amoebas eat. Okay, right here is a little tiny organism that the amoeba would like to eat. And so it's forming its pseudopods around that organism, and it's going to basically kind of trap it in there. And then the organism finally realizes that, hey, I can't get out of here, and tries to escape, but to no avail. It has been trapped by the amoeba's pseudopods. The amoeba then will dissolve that organism using the chemicals in its cytoplasm. Okay, another category of animal-like protists are those that move with cilia. Cilia are these little tiny hairs that surround the protist. They help it move by swaying back and forth really fast. And the most common example of an animal-like protist with cilia is a paramecium. Now this is what a paramecium looks like. It has a lot more organelles inside of it than an amoeba does. And if you look really closely on the outside there, you can see the little tiny hairs, the cilia, beating back very quickly. And they help that organism, that paramecium, move where it needs to go. Here's an artist's rendering of a paramecium. Kind of looks like a shag carpet on the outside, this paramecium, and you see these are all the little tiny cilia that are surrounding it. This paramecium is actually being eaten by another animal-like protist called a didynum, and it also has cilia, but it has a different configuration of its cilia around it. And the third category of animal-like protists is those that move with flagella. And we learned about flagella when we studied bacteria. Remember, bacteria can also have flagella that help it move around. There are these long whip-like tails that just, beat back and forth in the water to help it move through those moist areas. Protists can have anywhere from one flagella, like on this example down here. There you go, some little flagellum right there. Or it can have a lot more. This one has 4. It can have all the way up to 8 flagella. Zooflagellates are a good example of a protist with flagella, and they're interesting because they live inside termites and they help the termite digest the wood that it's eating. Some animal-like protists with flagella can also cause disease. Pretty much in every category of protists, there's going to be some of those organisms that can cause disease. Kind of see right up here, these are the little flagella beaten back and forth. And they go pretty quickly. On your notes, please make sure that you record the common protists. These are going to be the ones that you're going to at least need to be familiar with, what they look like, what their names are. The amoeba is going to be your most common one that you probably heard of before. Please know that the amoeba moves with pseudopods. Giardia is another common protist, and it moves with the flagellum. You'll definitely need to know that these long string-like features here are the flagellum. And then you have the paramecium. And the paramecium, please note that they are the ones that move with the cilia, and they have those little tiny hairs all the way around. All right, I'm having a hard time going. All right, our next main category of protists are the fungus-like protists. They're going to be similar to fungus because they're heterotrophs. They also have cell walls, and they use spores to reproduce. So, fungus-like protists and animal-like protists are both heterotrophs, but fungus-like protists, they use spores to reproduce. The animal-like protists are not going to use spores to reproduce. They are unlike fungi because all of these fungus-like protists can move at some point in their life. And we'll see some weird little video clips of that a little bit later. They're also decomposers, which means that they can help break down dead organisms. Sorry, my forward button is not working so well. Give me a second. So some common fungus-like protists are the water molds. If you've seen mold kind of growing in a fish tank or something like that, it's not always going to be an actual mold. It's most likely going to be a fungus-like protist. Downy mildews, they're the ones that caused the Irish potato famine in 1840, all this yellow discoloration, that's the downy mildew. And my favorite is the slime mold. This is a picture of slime mold starting to form, but there's lots of different types of slime mold. Now this is my favorite slime mold.
Il y a un exemple d'organisme à la jonction unicellulaire multicellulaire qui est en fait une espèce de champignon primitif. Cet organisme existe à l'état unicellulaire dans de bonnes conditions alimentaires, disons. Et quand ces conditions alimentaires deviennent nettement plus mauvaises, les différentes cellules s'agrègent et au bout de 24 heures, on passe d'un organisme unicellulaire à un organisme multicellulaire.
Slime mold, the individual cells live as free-living amoeba crawling along on the forest floor. But when conditions deteriorate, then they do this remarkable social thing. amoeba come together to form a multicellular slug, this worm-like structure that crawls along trying to find a better environment. And then the worm changes into a small plant-like structure, which now creates these very hardy cells called spores. So cell death is involved in this unusual life cycle when the slug stops migrating and forms this little plant-like structure called a fruiting body. It forms a stalk, and the stalk is formed from the corpses of dead cells off the ground. And when conditions get better, these spores now germinate to give rise to free-living amoeba again.
So the slime molds are some really interesting creatures, and you can see that, guess what, fungi, the fungi kingdom, they're not going to be having, little fungi that's moving around and swimming around in moist areas and so forth. This is very, very different than the mushrooms and the mold that we've learned about in the previous lessons. And so scientists are like, hey, these can't belong in the fungi kingdom. They're just too different. And that's why they are considered protists. They're in the fungi-like protist category instead. Last category is the plant-like protists. You've probably heard of the term algae, and most people think algae are plants, but they are incorrect. Algae are actually in the protist kingdom. Okay, they are similar to plants because they're autotrophs. They make their own food using the sun. However, they are unlike plants for many, many reasons. Number one, they can be unicellular or multicellular. Okay, everything in the plant kingdom is always going to be multicellular. There are no unicellular organisms in the plant kingdom. But in the plant-like protist category of the protist kingdom, algae can be unicellular. Also, most plant-like protists live in water, and we're talking like fully in water. Plant-like protists also, they don't have the vascular tissues like xylem and phloem that we learned about in 6th grade. Remember, xylem and phloem help transport the water and the food for the plant. Okay? And plant-like protists do not have those kind of tissues. And some plant-like protists can move. They can move around. There's one called the euglena that can actually has little cilia as well that help it swim through the water. Actually, I'm sorry, I think the euglena has a flagella. I take that back. I really do want you to highlight this first line here so that you don't forget. Super, super important. If you don't have a highlighter, you can also circle it, put a star by it, whatever you need to do. But you need to remember that algae does not belong to the plant kingdom. Algae belongs to the plant-like protist kingdom. Okay. All right, let's take a look at some of the common plant-like protists. Okay. This is the euglena, and this one does have a flagellum. Okay, so you'll see right here, this is kind of what it looks like when it moves around. This is one of those that's an interesting, like one of those weird organisms. It could be considered an animal-like protist because it can move, but it also makes its own food because it has chlorophyll in it. So it's kind of one of those weird ones as well. It doesn't quite fit into either one of the subcategories, but we're going to stick with the plant-like protist because it makes its own food. Another interesting thing about the euglena is that it has an eye spot, and it's not like an eye that like our eyes can see, but it just is like a sensor. It senses light. So if there's an area where there's light, then the euglena is going to stay in that area because it's going to want to use the light to make sun. If it's in a dark area, the euglena is going to keep moving until it finds light so it can absorb the light and then turn it into food. Diatoms are another unicellular plant-like protist. And you'll see that they have all sorts of different shapes, colors, sizes. These are all found in water. Many of them are found in the ocean. And these are just some of the common plant-like that we have. Oops, sorry. Okay, down here over on this side, these are all diatoms right here. Okay, they come in all different shapes and sizes. Over here you see toothpaste. Actually, a lot of toothpaste is made with the dead skeletons of diatoms. Sorry to gross you out. But it's just, what happens is when those diatoms, you see how they look very glassy? When they're all crushed up and the skeletons are all crushed up, it creates an abrasive feeling like sandpaper. And so it's easy to mix it into a paste, and therefore those little tiny bits of the skeletons rub up against your teeth and break away the plaque and the tartar and so forth, and clean it up.
One avenue to healthier living started very tiny and a long time ago. Yep, about that long ago. But we said tiny. In both salt and fresh water, a little single-cell plant called a diatom, we might think of it as plankton, lived in communities with billions of billions of billions of other diatoms. They are the basic food of water-dwelling creatures. Even these guys depend on them. And diatom communities are a popular tool for monitoring environmental conditions, past and present. But those that were not turned into food, well, when they died, they settled at the bottom by the billions of billions of billions. Bring it forward to today. The Earth plates have moved and things have shifted, and we can now easily get to the fossil remains of these diatoms, and we call them collectively diatomaceous earth. Of the 600 deposits found in the U.S., 4 of them are of a quality considered food grade. These were once diatoms living in freshwater, and therefore have a harder shell and are less fragile than their saltwater cousins. Under a microscope, they look like a cylinder or a tube with holes in it. Even though they are called food grade, they are not really food because they do not digest. They pass all the way through the body, and everything it does is either physical action or electrical action. These cylinders have a powerful negative charge, and the holes are the right size to absorb positively charged viruses and bacteria, hold them, and take them out of the body. Each tiny shell can hold and neutralize many positive particles. When consumed, these cylinders by the millions pass through the stomach and intestines and destroy parasites. Their abrasive quality makes this a physical action, not a chemical one. So this is Mother Nature's very own organic recipe that has developed over millions of years. Use of diatomaceous earth has been reported for use as detox and cleansing to help with inflammation, arthritis, bone strength, osteoporosis, tissue repair, digestive aid, and chronic fatigue, just to name a few. Like any health supplement, talk to your healthcare provider before starting any supplement or program and see if it is right for you.
So diatoms, we're still discovering new ways that we can use these diatom skeletons. So kind of interesting. Keep an eye out for it. Please just don't go to the store and go buy a diatomaceous earth and start eating it. It's something you need to talk to your doctor about. Make sure it's okay for you, though. Okay, the last group of plant-like protists are the like the seaweed here. You've probably all heard of seaweed, and seaweed is actually a protist. It's not in the plant category. Okay, you have lots of different types of seaweed. You have like brown seaweed, you have green seaweed, and you also even have red seaweed. Seaweed, once again, it looks like a plant, but it doesn't have those vascular tissues as the xylem and the phloem. Okay, they live completely submerged in water. So we're not going to; these aren't considered plants. They look like plants. They can they're autotrophs like plants, but they just don't have all the same qualities and the same characteristics as plants do. So that's why they are not in the plant kingdom. Okay, on your notes, please make sure that you label the different plant-like protists that are here. Okay. Oh, I forgot to mention, they also aren't considered plants because they don't have the true leaves or the roots. So like the same root system, very, very, very small, very weak roots. They don't go down very far because what's the purpose of roots in a plant is to absorb water. Well, the seaweed lives in the water. They have plenty of water, so they don't need that same root structure. The roots are only there mainly to hold them in place. And I don't remember if you have this slide or not, but once again, these are just the reasons why they're not considered to be in the plant kingdom. Okay, last little video we're going to watch. I think I'm going to upload it for you instead because I think this one's getting kind of long, okay? But this last one's just going to talk about how algae can possibly, maybe one day, make energy and be another energy source for our planet.
And algae.
Here is your assignment. It is going to be to read your textbook, page 218 and 227, and you have some workbook pages to go along with it. And then you can just have that turned in with your packet to the substitute. All right, we'll catch you later. Bye.